This video is brought to you by Sporlan, quality, integrity, and tradition.
I'm here today on a follow-up because I had another service technician come out here yesterday on an emergency service call for the walk-in cooler not working. And when he arrived, he found that the number 2 fuse in the disconnect switch was blown, but he couldn't find a reason why the fuse would blow. So he reset it, and it's been running for almost 24 hours. But it's Saturday now, and I just don't feel comfortable. I just kind of wanted to get my eyes on it. We may or may not find a problem, but I'm just going to open this guy up and see what we can figure out. This is older equipment. We were looking at the history. It's from 1997. Certainly can't get stuff that'll last this long anymore. This looks like it's an original compressor still, 97. It's a pretty simple system. It's a walk-in cooler with a pump down solenoid downstairs. Everything downstairs is on its own individual circuit breaker. So we had a 3-phase breaker, 3-phase fuse, so the number 2 fuse in that disconnect switch was blown. So the problem more than likely is going to be up here. It's an independent evaporator basically. So we're going to open this guy up. I don't see anything crazy jumping out at me yet. The box is down to temperature right now, so that's a good sign. I do not have camera footage, but when I walked into the box, it was at 37 degrees, but it was in defrost, okay? And then I walked up here and it was running, but honestly, judging just from my experience, the compressor didn't sound like it had a load on it. So I'm gonna get some service gauges on this. As I was taking this cover off, I noticed that when I dropped this, it turned off. So we could have a pressure control that's starting to fail or starting to drift. But this is just a preliminary idea. Temperature wise, I mean, it doesn't tell you a whole lot when it's not running, but I was curious if we had a restricted suction filter. Again, I'm just doing a visual right now. So I am gonna go get some probes. That contactor certainly looks older, but nothing is jumping out at me in here. Doesn't look horrible. We'll open this guy up, get this guy taken off, get a look inside the back of there. I mean, everything on this is like almost original. This is crazy. You know, they really don't make stuff like this anymore. Open it up in here. I pulled the cover off the contactor. Certainly does not look good in there. That contactor looks horrible. So that's not a good sign. But we're not gonna just stop there. We're gonna keep going. I'd be suspect to that disconnect switch. Interesting. Oh no, that was just the refrigerant sometimes can leak by or boil out of the oil of the compressor and turn the system on for a split second. So we definitely need to get some service gauges on this so we can understand exactly what's going on down here. So of course, this is how this works. It's raining on me right now. Go figure. It's not hard yet, so we're gonna keep working on this. But the pressure control doesn't look to be malfunctioning. It looks like it's set to cut in about 68 PSI and it has a 35-degree differential. So it's shutting off, I think, about where it should be. I definitely don't like that contactor. So we're gonna wait for it to cycle again and then just kind of operate or watch the system operate. I'll give it a few more minutes. It's not raining too hard yet, but I don't necessarily want to be stuck up here if it's working. But that contactor is definitely suspect. Pulled off the cover for in here. Definitely looks like maybe some wires rubbing in that back corner, but I don't see any arcs or anything. I mean, everything on this looks pretty darn decent, besides it being old. Probably be a smart idea to pull the defrost clock, bend it over, look at the back terminals, make sure there's nothing funky going on there. Don't see any melting from loose wires or anything. I think we are getting ready to turn on right now. I think that the system is calling. So we're just waiting for the, I thought I heard a solenoid valve open, so we're gonna give it a second. I'm gonna change the contactor, but I wanna see it turn on and see if we can test for a voltage drop across that contactor. I did not measure any voltage drop across the contactor, but we went ahead and changed it anyways because it looked really bad. We are running slightly low on the scale. That does happen from time to time in this area. 200 volts, that's a little bit low. 200 volts. So I can certainly see with voltage like that and a load like that compressor that a pitted contactor could, you know, you're gonna start to see some higher amps for sure. Everything's looking good. I mean, refrigerant wise, we're running a clear sight glass. I'd like to see that head pressure a little bit higher. Let's come on over here and grab. Discharge is hot. Liquid drain is cool. Liquid line is warm. So the head pressure control valve certainly is bypassing, and it's running through. That's fine. What else is going on here? We're gonna test for some temperature drops across the dryer real quick, just to make sure. All right, we've got 88 degree liquid line coming out of the head pressure control valve. We've got a 67 degree liquid drain, so it's shutting off the flow coming out of the condenser. And we have a 172 degree discharge line. So we're certainly bypassing on our head pressure control valve. All right, now we're gonna test the temperature drop across our dryer. We could do pressure too, but temperature is easy enough. So 85 degree coming out. Move it over to here. It's like 86 degree going in, so it's about a 2 degree temperature drop. It's probably okay. It's slightly an issue maybe. I'm just gonna grab this guy. This is coming out of the suction dryer. 54 degrees. Now let's look at going into the suction dryer. 47 degrees. So we're gaining heat, but that's to be expected because you're coming from insulated to non-insulated. As we get closer, look at, if I move it closer, the temperature drops. So yeah, it's losing heat, but we do have a pressure port, so we'll go ahead and check pressures across that guy real quick. We're at 37 PSI on the outlet of the suction dryer, so we need to get a pressure reading right here. Looks like we have a slight refrigerant leak right there. I don't know if that comes across. It's about that's interesting, a 2 PSI gain. Huh. I'm intrigued by that. I think, oh no, there we are. Yeah, it's about a 1 PSI, but it's gain, so I think we might be pumping down or something, or dropping up. There we go, we're at 37 now. So no, it's really no pressure drop across the suction dryer. I'm not seeing any issues there. I came down to the disconnect switch. We had just put new fuses in here yesterday. I checked for a voltage drop across the disconnect and I don't see any. It doesn't look like there's any problems in here. The knives seem to be making good contact. Don't see an issue there. Yeah, I'm not seeing anything else going on with this guy. Open up the back of the contactor. I mean, it doesn't look great, but it doesn't look horrible. The points aren't the greatest, but they're not burnt, really. Everything seems to be working. One thing I didn't check is, does this have the right time? And it does not. Oh, but this clock's not even being used. Yeah, this clock's not even in the picture because we have a KE2 temp plus defrost controller downstairs. So this clock really could be taken out of the picture if we want to. So I'm eliminating the stuff that doesn't need to be here. And in the meantime, while I'm doing that, I'm checking the system for potential places. So that defrost clock was still wired into the system, but it wasn't being used. So just yanked it out. And then in yanking the wiring, what I'm finding is the wires are too short because they were running to specific places. So just pulled 2 new wires to the pressure control really quick. It's not taking me long at all. And I'll wire those into the contactor. And then we'll investigate this crankcase heater. We'll probably have to extend these and get them wired into the contactor. But other than that, everything else is looking pretty good so far. All right, I cleaned up the wiring, made it easier. It's pretty self-explanatory now. Let's see, power comes off of line 1, goes through the pressure control, comes out of that, goes into one side of the contactor coil. Line 2 jumps directly to the other side of the contactor coil. So the pressure control is the thing that is responsible for solely opening and closing that contactor. Simple as that. 3-phase power coming in the top, 3-phase load exiting the bottom, condenser fan motor on these bottom 2 wires right here exiting the bottom. Everything's good. Defrost clock's eliminated. Crankcase heater's wired back in. I've got the compressor plug opened up. I didn't see any issues with the electrical in there. We're ohming it out. 1.6 amps. I'm sorry, 1.6 ohms. 1.6 ohms. 1.6 ohms to all 3 legs. So we're gonna go ahead and do a megger test on it too real quick. All right, run a test at 500 volts. It's a 208 volt compressor, greater than 550 mega ohms. So don't see any problems there. Everything's looking good. I'm not seeing anything that's telling me this thing should trip. You can see that should blow a fuse or anything. We put in a new condenser fan motor. I did it. You know, there's not a whole lot you can do about this because you don't have the OEM stuff anymore. So we made sure that the wiring is secured with zip ties so it's never going to rub out. Everything's nice and secure. There's no potential for shorts on the condenser fan motor. We'll verify that it's running at the right current, but I don't see any issues with that. Other than that, I don't see any other things going on up in here. Everything seems fine. One thing I will say is that disconnect switch is kind of redundant because you have a breaker right there and then you have a breaker downstairs. I guess maybe per code you have to have it externally because in order to get to that breaker you have to open this unit up. I'm not a huge fan of using fuses on a 3-phase system because in our situation 1 fuse blew and potentially single phase the system. Now in our situation the fuse that blew actually was the control circuit, so it shut down the contactor, you know. So I'm not seeing anything else going on with this guy. Yeah, I don't know what else to tell him. The condenser fan motor is allowed to run 2.9 amps. We're running undercurrent on that. And the compressor, I'll have to get on the clamp on there and then we'll pull up Copeland Mobile and see what we're allowed to run on that too. The compressor is running right at about 6.7 amps, and let's do some research on Copeland Mobile app and see what this guy's allowed to run. I'm in the Copeland Mobile app right now. Really simple. Gives you all the information for the compressor. You can go home. You basically, this is it right here. I searched it, find the right one, high temp, 233 phase. You've got all this information. Mechanical, gives you information on that. I mean, tons of stuff. So we go in here, we go to electrical, we go to summary. RLA is 12 amps. I mean, I'm not seeing any issues. Winding resistance 1.3, we're good on that, you know. Everything looks good. So we're yeah, we're good as far as the compressor goes right now. I've done pretty much everything in my power to try to find why this thing would have blown a fuse, and I don't see any issues. I inspected the disconnect switch. Certainly it's older, but I don't see anything wrong with it. I don't test any voltage drop across it. Before I even ran the megger, I went while the system was running and jiggled every conduit to see if maybe there was a short in the conduits. No, nothing. I certainly could start megging every wire, but I don't really see the need in that. Motor's running fine, current's good, electrical connections inside that box are good. I ended up, just because the wires were too short, I ended up replacing the wires in the pressure control, but there was no issue with those. I inspected them when I pulled them out. Compressor ohms out proper according to Copeland Mobile. You know, disconnect switch, I tightened all the electrical connections. Went ahead and replaced the contactor because it didn't look good. That certainly could have been a problem, okay? We are running a little bit lower on the spectrum as far as the voltage goes, but we're certainly within tolerance, okay? It does happen here where we're running right at 200 volts. In the summertime, we'll probably hit a little bit lower. They'll get like 198, which, you know, you don't like that, but still it's within tolerance. Now, you know, we have issues like this in certain areas, certain cities. You know, they just have poor electrical distribution. Now, yes, I know there's a million people that's going to say call the utility, get the voltage raised, buck boost transformers, all that stuff. You know, I leave that up to the customer, okay? You have to draw a line somewhere. And I'm going to let an electrician deal with that kind of stuff. I'm going to stay in my lane. You know, if it was just one individual feed, then we'd get an electrician involved, you know, but this is the entire building. This building is always operated like this too. So at this point, I have done everything that I can think of at this moment, you know, to make sure that everything is good. All right, this is certainly older equipment. This is an older coil. It's kind of hard for you guys to see, but this is a reverse airflow, so it sucks in through there and blows out that way. So it is a little dirty on the evaporator coil. That has nothing to do with our fuses blowing at this point right now. The box is down to temperature. Like I told you guys, there's a Ketatherm Temp Plus defrost controller right here. Everything else seems okay. So we're gonna tell them to keep an eye on it. And yeah, I can't really figure anything else out that might be going on, so we'll just tell them to watch it. All right, so I went ahead and pulled the contactor out. I didn't disassemble it on site, but I took it back to my shop. I'm sitting in my office right now, and I'm just pulling it apart just to get a visual. So we don't know exactly what caused the fuse to blow, okay? At this point, we're gonna have to use our education and make an educated guess, okay? We look at everything, right? We try to look at the big picture. We try to solve the problem and not just the symptom. The symptom was the fuse was blown, but why? Okay, so we're going through everything. There's always intermittent problems that don't always present themselves at the time of the diagnoses, okay? But, you know, we just look at everything. And this contactor, I'm not a huge fan of. While it was still operating, and technically when I tested it at that moment, it did not have a voltage drop across the contactor, you can clearly see that the points do not have very good, you know, they don't look very good basically. Okay, now these points right here are the contact points, okay? They go inside this contactor, you know, I disassembled it. These aren't really field repairable. This guy, you know, is kind of a pain to get apart, but once you start taking them apart, you kind of get used to them. But these points right here are the point of contact. Boom, makes contact like that. Okay, so it just goes boom, right? And it has to make a good connection there, right? And we clearly have deterioration of the points right there. Carbon buildup, you know, all kinds of crazy stuff. Now this contactor is an older contactor. It's not original. I don't necessarily see a date. Sometimes there's a date code on them. I don't know if any of this is the actual date code, but this is an older contactor. I'd say this is probably about 10 years old, judging by the looks of it. But we changed it out of pure precaution, but at the same time, this could have been our problem. We clearly were running on the lower end of the voltage scale, right at about 200 volts. That tends to make everything run a little bit warmer. So, you know, we just have to do our best. And at this point, I made an educated guess. Of course, the customer was part of the conversation. They understand what's going on here, and I feel comfortable. I can sleep at night knowing that I pretty much did everything within my power, within reason.
The way that I look at it, as long as I do everything within reason in my power to try to solve the customer's issues, you know, I can sleep at night. I really can. And even if I have to make an educated guess, I'm going to use, you know, my skills and use my knowledge and say, okay, you know what? All this stuff is going on. The contactor, while it wasn't testing bad, it didn't certainly look good, and it's a pretty good possibility that that was part of the issue. Contactors pull in and out multiple times, and every once in a while, if you've ever witnessed it, they can make a bad connection, and it only needs to happen once for it to, you know, run lower than normal voltage to maybe one of the phases of the compressor, and then it causes a high current situation potentially and causes a fuse to blow. It's always possible that maybe there's something going on in the disconnect switch. I mean, there's so many different variables. There's so many things. It could be an intermittent problem. The compressor could be locking up every once in a blue moon. I mean, there's so many different things going on, but we kind of attack looking at the low-hanging fruit, just kind of using everything, right? And of course, keeping the customer in the loop, letting them know, hey, there's always a possibility this could happen, this could happen. Let's change this contactor. It's going to become a problem sooner than later. And, you know, I feel comfortable with that. So I just try to do my best, really, okay? It's amazing, all the support from all of you. You know, the views, the interaction, the comments, you know, it's amazing. You know, do me a favor, you know, if you guys get an opportunity, share these videos with your friends, with your colleagues, with people that you think might be interested. You know, I never intended for these videos to become what they were. And one of the unintended, I don't want to say consequences, but a cool benefit is the emails that I get from people that say they got into the trade because they randomly got suggested these videos and then they thought it looked interesting. So now they're air conditioning and refrigeration technicians. That's a really cool, accomplished feeling for me. It's really neat. So I really appreciate you all. I cannot announce anything yet, but got some cool stuff we're working on right now for the future. Realistically, it's probably even too soon to tease it because it probably won't happen for another 6 months to a year, but there's some other cool things coming into the picture. Some new educational resources and different things. So should be fun. This is looking like it's going to be a great year. You know, this 2022, I'm hoping, you know, I could use some good things. I could use some good vibes. I can use all that. And I'm sure you could too. You know, 2020, 2021, definitely interesting, eventful years for a lot of us, right? Remember, guys, we really don't know what we're all going through. And it's so easy to assume the worst in people, but sometimes people might just be having a bad day, right? So I'm not excusing for people for being jerks or anything like that, but just remember, you know, be nice to one another, right? Be kind. You never know what someone's going through. And the simplest random act of kindness from you might change their day for the better. And if we all think that way, you know, maybe we can positively influence the way that things are going. You know, there's so much hate, so much fear right now. And I think that one thing we can do is just have some positivity, right? Share some kindness with people. I really appreciate you all. Remember, if you haven't already, please consider subscribing to my YouTube channel. Check out my website, hvacrvideos.com. Got merchandise if you want to help support the channel. Number one seller on the website is these hats. Put a lot of effort into them. They're black underbill on them, so that way our dirty fingers don't ruin the hat. They're a breathable material, so they're really good in the summertime. I wear these hats. I love them to death. Let's see. Upcoming here at the end of January, I will be at the AHR trade show with my buddy Brett Wetzel from the Advanced Refrigeration Podcast. We will both be at the Sporlin booth each day, or actually for the first 2 days of the trade show, we'll be at the Sporlin booth for a good part of the day. We'll also be doing a live stream together Monday evening, which will come out on YouTube. I will also be spending some time at the Refrigeration Technologies booth with John and Mike Pastorello. Great guys, so I'll definitely be spending some time over there. Also, at the end of February, or middle of February, I'll be at the HVAC School Training Symposium in Claremont, Florida. Brian Orr is putting this event on, so I'll be a speaker at that event, and some of the overtime guys, Bill and Adam, will also be there. So stay tuned for all that. There'll definitely be footage, and I'll announce stuff on social media and all that. But if you're going to make it to either one of those events, definitely come up and shake my hand, say what's up, all right? I really appreciate you all, and remember, be kind to one another, and we will catch you on the next one, okay?